Alright, welcome to another episode of Science with Surbeck. Today what we are going to be talking about is a review of the very essential elements of the periodic table. So, before we get going in this video and taking notes, I want you to be able to accomplish these objectives at the end of this video. Number one, identify all parts and pieces in the periodic table of elements. Number two, be able to determine the atomic number of protons and electrons in a neutral atom, and then given an element symbol or the name of an element, be able to find the number of protons, the atomic number, and the average atomic mass. So what we have here, right here in the center, is an example of what you would find, or the information that you would find on the periodic table. So the first thing that I want to identify here is this big whole number, and in this case it is a 6, and what this is, that number right there is known as the atomic number. Now, the atomic number, to give you a definition here, the atomic number is defined as the number of protons in the nucleus of an atom. Now, this atomic number is unique to each and every element. And the other thing to note here is that in a neutral atom, meaning a non-charged atom, the number of protons is equal to the number of electrons. So that means until I tell you we're working with ions, the atomic number will equal the number of protons and electrons until we get to ions. The next portion that you will find for each and every element or every box on the periodic table is going to be the element symbol. And the element symbol is either a 1 or 2 letter combination that is unique to each and every element. So, something to keep in mind, the first letter of an element symbol is always going to be capitalized. The second letter, if there's some elements that only have one letter, if there is a second letter in that elemental symbol, it will be lowercase. Now, we need to be careful with our elemental symbols. And so my example that I have here is both with the same letter combination, but I didn't take the time here on that second one to make sure my element symbol was lowercase. So over here on the left, everyone see it has a capital C, lowercase o. This is the element cobalt. And C, capital O, both capitalized here. This right here is carbon monoxide. So just by capitalizing or not capitalizing a letter determines if we are actually looking at an element or a compound. So we have to be really, really careful when we write our elemental symbols and when we write our formulas in our chemistry class. Now, the next thing down that you will see in every elements box is going to be the name of the element. And I'm going to put this up here. So in this class, because I give you a periodic table, the names of the elements need to be spelled correctly. The other thing to be aware of is that the first letter of the name might not necessarily match up with the first letter of the symbol. The last thing that you will find and identify on the periodic table of elements is this number with a decimal. Now, this number with a decimal is an element's average atomic mass. Now, the average atomic mass is expressed in the unit of AMUs, or that's abbreviated for atomic mass unit. The other thing to note here is that there is a decimal for almost all elements on the periodic table because there are isotopes, or this number is an average of all the isotopes of that particular element. Okay, so those things are everything that you'll find on the periodic table of elements, and they will help us answer the next set of questions. So what I'm going to do here is I'm going to transfer pages, and what I will go through and what I will do is out to the side here I have a fresh, clean periodic table of elements, and we will just go through each of these questions that relate back to those notes we just took. So the first question is, what is the atomic number for iron? Now, iron is the name of an element, so what we need to do is we need to look on our periodic table for the name, and it's written real small here on the video, but you can see the name of each of the elements on the periodic table, and we get to this of iron. So iron, if we look for the atomic number, this will always be the whole number. So the whole number associated with iron is 26. So our answer for the atomic number of iron becomes 26. Now, something else to note, that the atomic number is also equal to the number of protons in iron. Now, because I have told you, hey, until we get to ions, we can assume everything is neutral. So in a neutral iron atom, we have not only 26 protons, but also 26 electrons. Now, the next question is this. How many protons and electrons does Fr have? Couple of things. Notice with the symbol, we have a capital letter followed by a lowercase letter. So that should indicate to us that we have an element, not a compound. So again, very important to pay attention to those details. So again, the first thing, or now what we need to do, is look for the element Fr. So we scroll and we scan across the periodic table, and we get to something called F. But notice that this does not have Fr. So we have to keep looking. We keep looking, we keep looking. There's another F, but that's Fe. And we finally get down to there. All right, so that is F little r. So we want to know what is the number of protons and electrons in a neutral Fr. That number is equal to that atomic number. So because the atomic number is 87, that atomic number in a neutral atom is going to be equal to the number of protons and the number of electrons. So for our answer for francium, we have 87 protons. And because we are in a neutral atom, we have 87 electrons. Okay, so now we keep moving down and we want to go from the element name to finding the symbol. So we want to know, what is the element symbol for tungsten? So we have the element name. Again, they're kind of small when I show it on the video, but we go through, we keep scanning, and at first glance, you may not find the element name for tungsten. But keep in mind that not all first letters of the name and first letters of the symbol match up. So for tungsten, I'm going to zoom in here. See right here with tungsten, that's the name that I wrote down, and the symbol is a big capital W. So the symbol for tungsten is W. Again, be careful because the first letter of the name might not match up with the first letter of the element symbol. All right, so we move down to number 4 here. We want to know, what is the average atomic mass for silicon? Again, I gave you the name here, so that means we need to search across the periodic table and find the element name for silicon. So silicon is right here, and then we have this average atomic mass. It will always be the number with decimals or in the bottom portion of the periodic table that we use. And so you see this number. It is listed at 28.0855. For us in this class, we want to round to 2 decimal places. So because we have 28.085, this 5 causes the 8 to round up. So the average atomic mass for silicon becomes 28.09 by the time we round up. Now, our units for this are atomic mass units, or we can just call that AMU. All right, so now what we're going to do, we're going to shift gears and we're going to go straight into that periodic table of elements and review some of the components of the periodic table of elements. All right, so in front of me, what I have is the periodic table of elements. And so what I want you to do is take notes as I write some things on the periodic table. So the first thing that I want you to remember and identify is that from left to right, these things are called rows, but more specifically, we are going to call them periods. So again, left to right, like this arrow that I've now drawn, these things are known as the periods. And if you want to know these are considered rows, and they move left to right. Now, on our up and down, or our columns, these columns are known as groups. So again, I'm going to draw an arrow here, but our up and down, these are known as our groups, and they are referred to often as columns, and they move up and down. Okay, so now what I'm going to do is I'm going to use 7 different colored pencils, and I'm going to identify the specific areas of the periodic table. So the first thing that I'm going to identify is group 1, or something that we refer to as the alkali metals. So the alkali metals, I have this pinkish color, and the alkali metals here are every group 1 element with the exception of hydrogen. So again, these group 1 elements are known as alkali earth metals, or excuse me, alkali metals, with the exception of they do not include hydrogen. So just to label that, just so we have a key, this color here, this pink color, these are known as the alkali metals. Now, if we go one group to the right, I'm going to color this in green. This green group here that I will shade in is known as the alkaline earth metals. So every group 2 element, the thing I'm shading in green, is known as the alkaline earth metals. And again, just to label this in our key, the elements that are green, these are known as the alkaline earth metals. Now we move over, and I'm going to highlight this in a dark blue color. We move over the next 10 groups, all the way from scandium, and it stops right after we get through zinc. And then we go down all of these groups to the very bottom here. And these 10 groups are known as the transition metals. So it's going to take me a little bit here to shade all this in. But again, these 10 groups are known as the transition metals. All right, there we go. And again, dark blue here. These elements are known as the transition metals. Now, right below here with our cerium and thorium, these elements right here, if you notice, it goes 58, 59, and up here there's 57, and then it skips to 72. These elements right here actually should be inserted in these bottom 2 rows, but it would make our periodic table really goofy. So what they do is they take those out and they put them at the bottom, but know that they should be in these particular spots or follow exactly these elements. And so these, and I'm going to highlight this in yellow, these at the bottom are known as the inner transition metals. Again, yellow here that we highlighted, these are known as the inner transition metals, and they should actually sit right next to lanthanide and actinide. These are known as the inner transition metals. Okay, so now what we do is we are going to shift over into our next section. And our next section of the periodic table is known as the metalloids. Now, the metalloids are going to form a stair-step line, and they are going to go all the way down here. Now, it's very important that we watch which ones get highlighted. So, boron is a metalloid. Silicon and germanium are metalloids. Arsenic and antimony are metalloids. And then our last metalloid here is beryllium. So again, orange here, what I just highlighted in orange, these are the metalloids. Now, something to note is that anything to the left of this orange stair-step line, anything to the left of the orange stair-step line, so aluminum, gallium, everything over to the left, these are all metals. So I'm just going to make an arrow here. Anything to the left of that stair-step line, these are metals. The metalloids are not metals. They're actually their own category. Anything to the left are metals. Now, we have two more major groups that we will label here. And so the first of these groups is fluorine all the way down to astatine. And I'm going to do this in this purple pinkish color. And this group right here that I just highlighted, they are known as the halogens. So again, this purple pink color here is known as the halogens. Now, our last major group that we label is going to be known as the noble gases. Now, I'm going to highlight this in a light blue. And so the noble gases are all the way on the right-hand side. And again, I'm labeling this in light blue. So light blue is going to be known as our noble gases. Now, there are two areas that we have not really talked about. The first of which is this big set of non-highlighted elements. And what I'm going to do here, just in regular pencil, I am going to shade this in pencil color. And these, they're still important, and we utilize them throughout this class, but these are known as the other nonmetals. So again, just shaded here in regular pencil, these things are known as the other nonmetals. Now, one thing, the other nonmetals also include our hydrogen. So we kept hydrogen out of those alkali metals. Now we need to include it. And that's because it really should lay over here. Another important thing is that anything to the right, any element to the right, is considered a nonmetal. So again, I'm going to draw this arrow, and these things are considered nonmetals. All right, the last thing here that we have are these elements that are considered metals. They're to the left of the stair-step line. And what I'm going to do is I'm going to give these things stripes. And these striped elements, these things are known as the other metals. So these things, I'm going to write this above, these striped elements are known as the other metals. All right, so I hope you learned a lot here. Hope you reviewed and helped you jog the memory of what involves the periodic table of elements. As always, make sure you subscribe.